what if you have hypothesized a model, you have specified the model, and you have specified your hypothesis, and you're gathering data and noticing some of the data is missing. So, what kind of consequence would this have for your analysis? So there are three kinds of missing data that you may encounter, and the first one is that the data are missing at random. Okay, so for example, that you survey 100 people, but at random you lose 20 of them. And this is actually no problem as long as you have enough remaining data, because you actually lost the data at random. It's like you still have a random sample, right? And the OLS estimates of the betas will be unbiased and consistent, and the internal validity is unaffected. But because the sample size is lower, you might, or you will have wider confidence intervals. So you will be less certain as to where the true values of the betas actually are. So what if the data are missing based on the value of x? So either high values of x or low values of x, observations with those, or one of those would be missing. For example, you estimate a regression of education x on wages y, and you only have data for those who attended university or beyond. Okay, this does not necessarily impose a threat to internal validity, but it might be a threat to external validity. Okay, because you estimate your model based on subjects or entities who has attended your university or beyond. So for this population, the set of people who have attended university or beyond, you can actually use the model on them, right? But it's not necessarily true that you can use the model on people with a different set of education levels. Okay, so the external validity might be subject to a problem. So furthermore, our OLS estimates, our betas, may be less precise, because if you disregard some parts of the range of x, then the variance of x will be lower, and from the formula for the slope, or the standard error of the slope, you know that the smaller the variance of x is, the larger the standard error of the beta would be. So, which means that the confidence interval for a beta would be larger, and you would be less certain as to where the true value of the beta would be. So the third way you could miss data is missing based on y. So for example, you estimate the effect of education on wages, and you survey workers, but some of the workers, especially those with higher salary, do not want to respond to the survey. Okay, and this is a kind of sample selection bias. Okay, and this might introduce correlation between the error term and the regressors, the betas, right? And then you would actually get biased results. Okay, this should be biased. So there are methods to rectify this, but this is beyond the scope of this course.